Okay, this is my video here for chapter 8, just to kind of talk about the questions and kind of give you some pointers for understanding the material in it, because obviously it's going to be needed for both the exam as well as the problem set, and just for just understanding things in general. Okay, so um, we start out here with a definitional question of what it takes to define a competitive market. What we would presume, right, when we're talking here about something being competitive, is that we have an entire market here where we have a demand and supply conditions, but that because it's so competitive, that for the individual firm, we see that this firm has no options in terms of how to price its product. That's supposed to be a straight line, which in essence gives us our price takers. If you're perfectly competitive, you don't care what your other competitors are doing, and you certainly don't advertise because your product is homogeneous, which then makes D obviously not relevant. Okay, so what about number two then? What do firms do in a perfectly competitive market? Well, what we know is that they don't sell a differentiated product. Part of the definition is that the product is homogeneous, meaning it's the same. Um, Transaction costs are high? Well, no, actually, the transaction costs are low. We presume that all the products are similar and that everyone knows what everyone is charging. Obviously, it can't be D, and we know that this is true, that firms do freely enter and exit the market, with the consequence of this being is that um, there is no long run profit. That's not required of this, it's just helping you kind of understand it even more. Okay, let's just kind of make this a little bit bigger here so things are even a little bit more clear. Let's take this down one notch. Okay, so now we're going to look at a market where we've given a demand function, we're given a supply function, um, and we have a market equilibrium of $45. So at this market equilibrium of $45, we're asked to um, find the residual demand for this firm. So $45 is what we would have found by equating the demand and the supply with each other. Um, the Well, let's actually just do it here just to make our lives a little bit more transparent here. 950 minus 10 times 45. So this would be on our demand side. On our supply side, we'd have negative 400 plus 20 times 45. That would be what, 450 plus 900 equals 500. Okay. So from our demand and supply side, in terms of residual demand, meaning anything left over, what we would see is that it is 0 units, right? Because demand equals supply. And then essentially we just need to resolve this. Again, everyone's is going to be different. It does it algorithmically, but what you need to do is you need to now substitute whatever price it gives you here into both functions. So in my case, I would do 10 minus 950 minus 10 times 43.74, and I would do negative 400 plus 20 times 43.74. That gives me 512.6. Again, yours is going to be maybe a little bit different here. Your number given might be a little bit different. But all I'm doing here is just plugging in that number that they gave me, that price. 457.8. Now what we can see here is that my demand side of it here is a little bit greater than my supply. So now I'm going to subtract the two from each other to get the residual. 57.28, and I get 55.32. Again, your numbers are likely going to be different. And then we are asked what the slope of the firm's residual demand curve is here. Well, then what you would need to do is you would need to find the unit change in the quantity for the unit change in the price. And that's going to give us our answer here. So in this case, I have a unit quantity change of 55.32, and I had a unit change in the price of 1.26 negative. And that gave me a negative 43.90. Dot. Okay. Number 4. Should a competitive firm ever produce when it's losing money? Why or why not? So this is kind of getting at that shutdown rule. So remember here for the shutdown rule, the firm would produce as long as it can cover its variable costs and at least some of its fixed costs. So this is number 4 is getting at the shutdown rule. So the correct answer is here. And if that's not clear to you, that's getting at that shutdown rule portion of this discussion. Okay, number 5. Whew, looks long. Okay, so let's start here. Okay, we've got a competitive firm here with a cost function, a marginal cost function, and revenue. And if the firm produces 150 units of output, we're then asked what's going to happen. So let's find out what its marginal cost would be. That would be 0.006 times 150 squared plus 22. Plus 22. Okay. And then marginal revenue. If I took the first derivative of this, the marginal revenue would just be 80, right? Because it would be with respect to Q. So what I'm seeing here so far is that marginal cost is greater than marginal revenue. We know it can't be this. We know it can't be that. Why do we know this? Because we don't really think in these kinds of terms of marginal profit, but the marginal profit being greater than 0, not the case because the marginal cost is greater than the marginal revenue. Revenue less than cost. Well, I guess we could solve this here. 80 times 150 is 12,000. And then cost, if I put in 150 there, that would be 50 cubed plus 22 times 150 plus 750 is 10,800. So the costs are greater than the revenue as well. Thinking I made a mistake here somewhere. Sorry, I think kind of, I would say it's fun. I think it's fun for you to see in real time me doing this rather than kind of having just a preformed thing being presented to you. Both can't be true. It can't be both A and B. I am absolutely firm that it's B, but why did I make a mistake somewhere about A? Let's just, if I put it in my calculator wrong, possibly. Times 50 cubed plus oh, sorry. No, sorry. No, I'm actually good. Shit. Yes. You probably were already seeing that and saying shiting. Are you reading the numbers wrong? It's not true. Sorry. My numbers are correct. It's just that the revenue is greater than the cost. I don't know why. I think I was seeing the numbers and just seeing 1,200, not 12,000. So yeah, we're all good. Okay, fun times. Okay, at this output level, what then are we seeing to be true? Well, with costs that are less than the revenue here, let's see here. What do we know is true? Would it be that profit is negative, or would it be that marginal product profit is negative? Well, in this case, um, it would be that the um, marginal profit is negative. And the reason why the marginal product is negative is because the marginal costs are greater than the marginal revenue. So we know that B is true. Why? Because marginal cost is greater than marginal revenue, where profit then is marginal profit is equal to marginal revenue minus marginal cost, which would mean that marginal profit would be a negative number. Now, the question would be, is profit negative? No, it's not. Profit's actually positive. How do we know that? Because revenue is greater than costs, which we actually found up there. Is profit positive? Yeah, we actually did find it because revenue is greater than cost. We know it's not D. It is both B and C. The firm's profit maximizing level of output. What would that be? Well, that would be where MR is equal to MC. So that would mean that it would be when 0.006 Q squared plus 22 is equal to 80. Sorry, this is the marginal cost. And this is my marginal revenue, which was just the first derivative of that function. Let's subtract the 22. 0.006 Q squared equals 58. And now I'm going to divide each side by 0.006. And then we get Q squared equals 9666. Oh my god, it's the devil. And then I'm going to take the square root of both sides. Sorry. 58 divided by 0.06. Second square root second answer Q is equal to 98.31, and it says just rounds to the nearest integer. So that would just be, oh, thank God, 98. I don't think your numbers will be different than mine. I think what's presented to you is the same. Okay, number 6. Suppose that the firm faces a price of $37, average variable cost of 30, and average fixed cost of 5. What is, in the short run, what is this firm going to do? So that would mean that the total cost, 21 and 5, that the total cost would be my AVC plus my FC. Well, I guess we could say the AFC times the quantity, or that ATC is equal to AVC plus AFC, which would mean for us here that 21 plus 5 equals an average total cost of 26. We've got a price of 33. So this firm is making a profit. Okay. Okay, let's look at number 7. So here we can't. I can't draw it for you in real time. So you'd be doing this on the system here. But the idea is we need to find the shutdown point. The shutdown point is going to be where I'm not making up my. So they want us to do it for both firm C as well. For one for where they're doing a conventional oil well, and one where they are fracking. So yes, the one shutdown point would be below where I'm not meeting each of these points here, where I'm not making each of those quantities. So this would be for the quantity for a fracker, and this would be the quantity for a conventional firm. Which would then mean, in terms of the supply function, if this were a fracking firm, would be the marginal cost function above the average variable cost, and this would be if they're fracking. And then if this firm were instead a conventional firm, the supply function would instead look like this. Because it could be anything above the quantities above the average variable cost. Okay. Okay, so now we have a competitive firm with a market price of 120, cost curve and marginal cost. Your numbers may be different here because I'm looking at least at another printout here that's got a marginal price here that's higher. So obviously you can make your own adjustments. And we need to find the profit maximizing level of output, the price, and the profit. Okay, so to find that output level, we need to find where marginal revenue is equal to marginal cost. Marginal cost we already have here of Q squared plus 20. Marginal revenue we're going to need to get from here. That's going to be using the power rule here, 3 out in front. So it's going to be equal to Q plus 20. Marginal cost is going to be equal to Q plus 20. And again, we're finding where marginal revenue is equal to marginal cost. So it'd be where Q plus 20 equals Q, where Q plus 20 is equal to Q squared plus 20. Okay, so subtract 20 from both sides, Q equals Q squared. Well, we can't have that, so where did we make a mistake? Give me a moment here. I'll pause it at least while I try to figure out where I made my mistake. It's because I'm trying to do this quickly here. Yeah, dude. The reason why this isn't working out is because all I did was did the work that they did for me. No wonder it's equaling nothing that makes sense because they found the first derivative here. Instead, I was doing more work than I needed to. So, because this is a perfectly competitive firm, the price itself is equal to the marginal revenue. So I just did more work than I needed to. Now, if I were a perfectionist, I would edit the video and remove my mistake here, but obviously, I think we all have better things to do with our time than that. And so if we just find the square root of 180, $13.41, so this is just going to be 13 units. The profit maximizing price, in this case here, it's the same thing. It's the same price that we already had, where we set marginal revenue equal to marginal cost. And then in terms of the profit level, that would be 120 times 13. That's going to give me my revenue. That's going to be 1560. And my total cost is going to be 1/3 13Q plus 20 times 13 plus 500. Okay, so I got total cost of 760. 0.36. And so then I would just take my total revenue, subtract my total costs. And get an answer here of about 800. Because that profit level is high or is above zero, the firm should certainly continue to produce. Okay, number 9. So here we've got some definitional questions again. So if a firm is in a short run equilibrium and it's earning a profit, what impact would a lump sum tax have? Definitionally, because this is a perfectly competitive firm and because it's earning a profit, at this point, it's not going to change its output, but it will earn a lower profit just because some of that profit is now going to be given to the state, to the government as tax revenue. If that firm that's currently earning a profit in the short run has instead an increase in its variable prices, now we would see that would actually change how much it produces. It's going to reduce it, and it's still going to earn that lower profit. So these are just definitional. Okay, now we need to derive the excess supply curve here. We're not going to well, how do I want to address this? We're not going to be doing this, I guess, is really the best way to say this. I don't know why the publisher thought this would be a good idea to give you even as a homework question. I don't agree with it. I even said that in the slides as well. You're not going to be responsible for doing this kind of question on the problem set. You're not going to see it on the exam. So you're not going to see it. Can't imagine very many sections of this course. I mean, obviously we're just one of um, three. I can't imagine any of the others are going to be covering this as well. The correct answer is A and B. And this is just if you're comfortable dealing with how to algebraically manipulate the supply curves, supply elasticities. It's busy work, to be honest, and I don't think it tells us very much about what's going on. Perfect question for you, huh? Okay, so now let's look at number 11 here. Now we've dealing with a demand function, and then something bad happens, and we need to look at how that changes. So there's a spill, but then there's also changing demand conditions as well. Okay, so let's zoom this out a little bit so we can kind of see most everything that's happening here. Okay, so first thing we want to see is we want to show the increase in demand. And we would see that right here, right where they're shifting out the demand function here. Then we would identify that new equilibrium point as being right here, as opposed to the old equilibrium point having been right there. Then we need to talk about what happens. We need to talk about what happens where the cleanup efforts are increasing the purchases of boat services, oil absorbing materials, and whatever. So now we need to talk about a situation. It really just goes all the way up there, I guess. Huh? It's just dumb. Sorry, I guess it really is that way. Okay. So here, you can't see it because when I made the PDF, it cut it off. But essentially here, we need to find for a firm, what we would see is that they are now, we've got the increase in demand here, but now what we would see is that these firms are going to be earning more profit. And so because these firms are earning more profit, then there would be entry into the market, which we can represent as the supply curve increasing and the price falls. So when you draw it, then you would be shifting out the supply curve. You had the demand curve shifting out. That was the first event that happened. Then you would shift out the supply function because of that profit level that exists, such that the end result is that the price never changed in the end. Okay. Oh, and then it just asks us to, with those things having been drawn there, the market price is not going to change. In terms of each individual firm, or sorry, the market quantity, the market quantity, let's see here. So the market quantity, oh, I see it permanently. Okay. So then we have a decrease. The price, the individual firm's output is not going to be changed. And the number of firms overall is going to decrease given this temporary situation that's identified over here. Okay. The country that's facing if the country is importing a small fraction of the world's supply, meaning it's a small demander, relatively speaking, then what would we expect to happen? Well, what we would see because it's such a small player, its supply is going to be relatively horizontal because it's such a small producer. But whatever this product is going to be perfectly elastic because it is such a small fraction, such that anything that they change isn't going to really affect the overall supply function. The market supply here is 0.4. The demand elasticity in other countries is negative 1.3, and it's a 10% share. So here, what we would be doing here, right, is that you would have to solve for number 12. You would have to go back to the thing I didn't want you to have to do here, but you would have to take the market supply, the residual supply, and solve. Again, I'm not having you do this, so it's like I'm perpetuating this thing here. Just trust me. I'm hoping your numbers are going to be the same as mine. We're not doing this. If I could remove the question, I would, but it won't let me. You're not going to see this on the exam because the exam I make. You're not going to see this on the problem set because the problem set I make. We're not going to see this. But how did I solve this? Or how would I solve this? Is I would use my excess supply function or my residual supply function equation here. Okay. I'm just going to pause here. Sorry for that delay there. Okay, so sorry, I'm also reading this at the same time here. So the FMCSA is going to be increasing some regulations. Okay, what effect do these new fixed costs have on the trucking market price and quantity? Are individual firms providing more or fewer trucking services? And we've got a perfectly competitive market. Okay, well, if that's the case, then what we're going to see here is that so here we've got a large truck here that's going to be fixed cost of $8,000, but these are lump sum, meaning that lump sum means no matter what you decide to do, essentially we could just say the cost exists. Now, what a lump sum specifically means is that we wouldn't change our actions because we can't go back and really, we can't go back in time and decide whether we want to operate the truck or not. It just exists. What that would mean for us in terms of the price is that the price is not going to change because the market's not going to be affected by this lump sum cost. And because the price is not changing, we're not going to see any change to the market quantity. We're not going to see any change to what individual firms are going to do. And also, we're not going to see any change, no change to the number of output nor to the number of truckers that exist. So essentially, in terms of this cost of business, in the long run, there's no effect at all. Because in the short run, we would see some of these changes around it, that some firms would exit the market. But in the long run, the costs are basically baked into the market. I know it seems really odd that they'd want to ask this specific question, but if you missed this part of it, um, then the problem would have seemed more difficult than it actually was. Okay, now we've got NAFTA, and that would allow for trade across U.S.-Mexican borders. And I do remember when this became law, that everyone was worried about low-wage Mexican truck drivers lowering wages for American truckers. Now, what we're saying here is that let's presume that pre-NAFTA, that the market was in a stable long-run equilibrium. So then these truckers entered the market. Now, the effects are going to be a little bit different, right? Because now we're taking a market that used to, this is the market, used to look like this, except now the supply curve is going to increase. There's going to be more truckers, which means that the price is going to fall, so decrease, that the market quantity is going to increase. We can see that here. Right, so the price is falling, the quantity is increasing. Each individual trucker then is getting a smaller share of this market because there's more truckers out there, and that would mean that there's fewer truckers out there and that they're providing less. So at least the economic theory would have justified American truckers being concerned about free trade, which is also just fills out our general conclusion that we reach about free trade, is that it does hurt individual industries, but that overall it's a good thing for American consumers. Okay, so now we have a metal chair manufacturing market with 78 firms. So N equals 78. The elasticity of supply is 3.1. The elasticity of demand is negative 1.1. Oh, and they want us to solve the residual again. I've already stated that I don't really care that much about this, but again, it's not just me. I don't think you'd find very many economists very interested in this. Okay, whatever. Let's just move on. This is just algebraic, mathematic. So I take the number of firms times the elasticity of demand minus, so now it would be times 77 times the elasticity of supply. Okay. 78 times negative 1.1 would be equal to negative 85.8 minus negative 324.5. I mean, I guess the only beauty of this, and with something that looks like that, that kind of elasticity as a residual demand curve, well, that would mean that we're pretty darn perfectly competitive. I mean, look at that. You change the price by 1%, and you've got a 324% change in the quantity. That's how you would read that number. That's pretty highly elastic. I mean, I guess I'll give the author the benefit here of saying that um, I guess this question, admittedly, does highlight the importance of it gives us a greater appreciation for how that individual firms' demand elasticity is calculated. Okay, that's about as good as I'll give it. But if you followed my math here and you especially understood the conclusion that given this number, this is a highly elastic number. Again, a 1% increase in the price causes a 324% decrease in the quantity. That would be highly elastic and have the consequence of a horizontal demand curve, or pretty darn highly elastic. Okay. So now we're imposing a specific tax per unit on these firms, and we want to look at how that affects their marginal and average cost. Then, in this case here, what we're going to see is that right. So we impose the marginal cost. The marginal cost goes up because of the amount of the tax, and it shifts up the marginal cost by that amount. So the vertical distance between the two is the tax. And it looks like it gets cut off here. Let's see if it gets kind of cut off, unfortunately, here. But what you would see here for MC2 is that essentially it's MC1 plus the amount of the tax, and that this shifts up also the average cost by the amount of the tax, which would mean that AC2 would just be AC1 plus the amount of the tax, which means that our new supply function is just that where the supply curve is our marginal cost curve, number 2, above the average fixed cost, which we don't see here, right? We're not given what it is here, but essentially, if you remember, we would have a average fixed cost that keeps declining. We have an average variable cost that looks like this. And essentially what we're saying here is that the supply function would be that portion above the average fixed cost, because the firm, yeah, I mean, we could add that, and then we could even add that. And we're saying here is that the firm can lose some money, that difference between the two, but at least it needs to make up the average fixed cost. Which then just means that supply curve 2 is S1 plus the tax. That's all that's shifted up by. Okay. And then continuing on here, that the how much are consumers paying of the tax and how much are producers paying of the tax? Well, that we would find by finding out definitionally. We don't actually have to. Sorry, what happened here? Why did I cut that off? Okay, that's not okay. This is definitional. This isn't unique to this problem here. That would simply be the difference in the prices paid divided by the tax. So there'd be some portion there. And in terms of producers, it would also be that same difference. Because now, why is this look a little different? Because remember, the producer receives the tax, but they ultimately have to give it back to the government. The idea is that P2 is going to be less than what they used to receive, and that's going to cover their portion of the tax, and that consumers are going to pay a higher price than before the tax, and that's going to be their proportion of the tax. And so these general equations are going to give us some idea of the proportion of taxes paid for by each group. Okay. And I think this might be the last question here. I just want to make sure here. What are they asking us to do? I see. Okay, so we have two types of gas, one that's regular and one that is a special blend. One that's for warm months and one that's for, I guess, not warm months. So we essentially draw the demand function. I don't think there's really anything too interesting about this. I'm just trying to see what is it trying to ask us here. Oh, okay. Well, sure. Okay, so it's just saying here, I think you'll actually see these graphs here, or you would be graphing them out. Essentially, you're just saying, what does it look like now as I start to add these different blends of gasoline? Is that what you could see is that if no one changes, their behavior, that what we would see here is that we could get a large increase for places that use a special blend. And that we could see this because what's happening here is that you've got successive groups that are asking for more and more of this gasoline. But then all of a sudden you get to that special blend, and look what happens there. The point where it intersects with the supply function goes up dramatically, and that would cause our much higher price, rapid increase in price, which is what the question is getting at. Okay. I hope this kind of helps you navigate this homework question, homework set.